Hi, we're going to continue our discussion of chemical equations by looking at the process of balancing chemical equations, which is a very important thing for students of chemistry to be able to do. First, a quick recap. What do we mean by a balanced chemical equation? So a balanced chemical equation has equal amounts of each element on both sides of the reaction. So an example of that is combustion of hydrogen gas in the presence of oxygen to form water. On the left side of this reaction, we have a total of 4 hydrogen atoms and 2 oxygen atoms. And on the left side of the reaction, we also have a total of 4 hydrogen atoms and 2 oxygen atoms. And so this equation is said to be balanced. There are equal amounts of hydrogen on the left and on the right, and there are equal amounts of oxygen on the left and on the right. And a balanced chemical equation satisfies the law of conservation of matter. In other words, it describes a situation where atoms are not being created or destroyed. All the atoms that go into the reaction on the left are coming out on the right. There aren't any atoms that are being lost. There aren't any atoms that are appearing out of nowhere. And the important thing about balanced chemical equations as far as their usefulness is that they show us the relative amounts of the reactants and products in a reaction, whereas unbalanced chemical equations don't. So for this particular example, the balanced chemical equation shows us that whatever amount of oxygen is involved in this reaction, twice that amount of hydrogen is involved. Now, if we're given an unbalanced chemical equation, there are a variety of ways to balance it, but generally speaking, we will balance chemical equations by hand. And we do this by adjusting the coefficients of the reactants and products, focusing on one element at a time. So the example that I'm going to start with here is zinc metal reacting with hydrochloric acid to form a solution of zinc chloride and hydrogen gas. So this chemical equation here is unbalanced. You can see that there are different amounts of chlorine on the left and on the right. There are different amounts of hydrogen on the left and on the right. And when we set about balancing a chemical equation like this, we want to look at one element at a time. So looking first at zinc here, we see that there's one atom of zinc on the left. There's a total of one atom of zinc on the right. So the zinc here is actually balanced already. So we don't need to worry about the zinc. The zinc is all set. Looking next at hydrogen, we can see that there's one atom of hydrogen on the left side of the reaction, but there are 2 atoms of hydrogen on the right. So hydrogen is unbalanced. Also, on the chlorine, there's one atom of chlorine on the left and a total of 2 atoms of chlorine on the right. So we've got 2 elements here that are unbalanced. The hydrogen is unbalanced and the chlorine is unbalanced. And when you've got a situation like this, you can freely choose which of those elements you want to balance first, hydrogen or chlorine. Sometimes you can balance both at the same time, but generally speaking, you want to focus on balancing one element at a time. The zinc is all set, and we can turn next to either the hydrogen or the chlorine. In this case, I'm going to focus on balancing the chlorine first. And the way I'm going to do that is I'm going to notice that I've got 2 chlorines on the right, but only 1 on the left. And I can fix that. I can get 2 chlorines on the left if I double the amount of HCl. So I'll go ahead and do that. And now I've got zinc reacting with 2 moles of HCl to form zinc chloride and hydrogen gas. And so now I've got my 2 atoms of chlorine on the right, and now I've got 2 atoms of chlorine on the left. So now the chlorine is balanced. That's all set. And the zinc is still balanced. We haven't done anything to the zinc, so it's still good. And now turning to the hydrogen, we can see that we've got our 2 atoms of hydrogen still on the right. And now, after doubling the coefficient of HCl, we now have 2 atoms of hydrogen on the left. So in the process of balancing the chlorine, the hydrogen has actually balanced out along with it. So that was kind of lucky. The hydrogen balanced out, and so we're actually all set. The zinc is balanced, the chlorine is balanced, and the hydrogen is balanced. Now, one thing that really needs to be understood about balancing chemical equations is, notice that I never changed any of the formulas. So I didn't change HCl, I didn't change zinc, I didn't change ZnCl2, I didn't change H2. The only thing that I changed was the amount of HCl. I changed the coefficient on the HCl. So that's really important. When you're balancing a chemical equation, you should never change the formulas of the reactants and products. You should only change the coefficients. So let's look at another example. When it's heated, ammonium dichromate decomposes into chromium 3 oxide, nitrogen gas, and water vapor. So that's a description in words of a chemical process. The unbalanced chemical equation would be NH4 taken twice, Cr2O7, which is a solid under normal conditions, reacts to form Cr2O3, also a solid, plus dinitrogen gas and water vapor, H2O gas. This is unbalanced. We can see we've got different amounts of the oxygen on the 2 sides. We've got different amounts of hydrogen on the 2 sides. So we need to fix this. Since this is a slightly more complicated reaction, I'm just going to put a dotted line here between the reactant side and the product side, just to keep things a little clearer about as I go about balancing the elements here. So I'm going to look first at the chromium. On the left side, I've got 2 atoms of chromium. On the right side, I also have 2 atoms of chromium. So in this case, the chromium is already balanced for us. That's nice. Looking next at the nitrogen, we've got a total of 2 nitrogen atoms on the left. Hopefully you can see how that we've got 2 nitrogens on the left side. We also have 2 nitrogens on the right side. So the nitrogen is also balanced for us. So far, so good. Now, when we turn to look at oxygen, though, we've got 7 oxygen atoms on the left. And oxygen appears in 2 places on the right. In the chromium 3 oxide, we've got 3 oxygen atoms. And in the water vapor, we have another oxygen atom. So we've got a total of 4 oxygen atoms on the right, and that does not balance the 7 oxygen atoms on the left. Also, if we look at the hydrogen, there's a total of 8 hydrogen atoms on the left, because we have the NH4, and that's being taken twice. So there's a total of 8 hydrogens on the left, and we've got a total of only 2 hydrogens on the right. So the hydrogen and the oxygen are unbalanced. They're both unbalanced. And again, when we've got multiple elements that are unbalanced, we can start with either one. And I'm going to start with the hydrogen in this case. And I'm going to notice that I've got 8 hydrogen atoms on the left. I only have 2 on the right. So we can easily fix this if we multiply the water on the right. If we multiply that by 4, so instead of having 1 mole of water on the right, if we have 4, now this fixes the hydrogen. We've got 8 hydrogen atoms on the left. We've got 8 hydrogen atoms altogether on the right. So now our hydrogen is balanced. And now we can look at the oxygen. we still have 7 oxygen atoms on the left side of the reaction. On the right, we have 3 oxygen atoms in the chromium 3 oxide. We now have 4 oxygen atoms on the right in the water. So the total amount of oxygen on the right is now 7. So actually, by balancing the hydrogen, the oxygen balanced at the same time. So our oxygen is all set. And this is something that will often happen when you're balancing a chemical equation. It doesn't always happen, but very often what you'll find is that as you're working your way through balancing the elements, oftentimes the last element that you look at will balance itself during the process of balancing the others. This isn't always going to happen, but it happens often enough that it's worth commenting on. So I want to look next at a more complicated chemical equation where there's a little bit of strategic thinking that goes into choosing which elements to balance first and which ones to do later. So in this case, I'm going to look at combustion of ethanol, C2H5OH, reacting with oxygen gas to form carbon dioxide and water vapor. So here's our unbalanced chemical equation. And if we look at this equation, we can see that, oxygen is actually balanced already. There's 3 oxygens on the left and 3 oxygens on the right. But the carbon and the hydrogen are both unbalanced. And so we could start with either one of these. We could start with balancing the carbon or the hydrogen. And in this case, it doesn't really matter which one we start with. My personal preference is I like to do hydrogen last if I can. And so in here I'm going to start with the carbon. And so we've got 2 carbon atoms on the left side of this chemical equation. We've got 1 carbon atom on the right. We can fix this by doubling the coefficient of CO2 on the product side. And so that gives us our chemical equation C2H5OH plus O2 gives us 2 CO2 plus H2O. Now we still have 2 carbons on the left and we have 2 carbons on the right, so that takes care of carbon. Now if you look carefully, so the hydrogen is still unbalanced, and actually we've broken the oxygen. So the oxygen was originally balanced and now it's out of whack. Now we've got 3 oxygens on the left and we have a total of 5 on the right. And this is something that will often happen. Oftentimes by balancing one element, you'll knock another one out of kilter. And that's a very common thing to happen. And so you don't want to panic if you see that happening. We can come back and we can fix that. But it is, we still do need to pay attention that we've got 2 unbalanced elements. Hydrogen and oxygen are unbalanced. And what I'm going to, as far as which one to look at next, notice that on the reactant side, hydrogen only appears in one place. And on the product side, hydrogen only appears in one place, whereas oxygen appears in both of the reactants and in both of the products. So the situation with hydrogen is a bit simpler than it is with oxygen. And so I'm going to look at hydrogen next. We don't have to do that, but we'll make things a little simpler for ourselves if we look at the element that appears in fewer places. So doing that, on the left side, we have a total of 6 hydrogen atoms. On the right side, we have a total of 2 hydrogen atoms. This is pretty easy to fix. We can get 6 hydrogen atoms on the right if we triple the coefficient on the water. So instead of just having water, we have 3 waters on the right. And so now we've got our 6 hydrogens on the left. We've got 6 hydrogens on the right. So hydrogen is balanced. The carbon is still balanced. We still have 2 carbons on each side. And now, finally, if we look at oxygen, we've got a total of 3 oxygen atoms on the left and a total of 7 oxygen atoms on the right. 4 of them are coming from the carbon dioxide, 3 of them are coming from the water, so there's a total of 7 oxygens on the right. Now the tricky bit is we want to balance the oxygen, and if possible, we want to do that in a way that doesn't unbalance the carbon and the hydrogen. So one way that we could balance the oxygen is if we multiply all the coefficients on the left by 7 and we multiply all the coefficients on the right by 3. That would give us 21 oxygens on the left and 21 oxygens on the right, which is good, but it would break the carbon and hydrogen. It would knock those out of balance. So let's see if we can find another way to balance the oxygen. And we can take advantage of the fact that oxygen appears in multiple places. So if we look, and instead of thinking about multiplying, notice that we've got 7 oxygens on the right, we have 3 on the left, and so we need to have 4 more oxygen atoms on the left side of this chemical equation. And one way that we can do that is if we add 2 more oxygen molecules. So if we add 2 more of the O2s for a total of 3 O2 on the left side, now we still have 7 oxygen atoms on the right, but now we've got 7 oxygen atoms on the left, and so the oxygen is now balanced, as is the carbon and the hydrogen. So this finally is a balanced chemical equation. And that's where we're going to finish up this video.